Another method is called Simpson's rule, which is very commonly used. Now, the trapezoid method approximates each subinterval with a linear approximation. Remember that trapezoid? If the curve looked like this for a piece of it, we took and went to here, here to here, and made a trapezoid out of it. This is the linear approximation. I'm using a linear approximation, a line, to approximate this curve, then find the area underneath it. Now, we might be able to gain some accuracy by approximating each subinterval with a second degree polynomial. In other words, use some type of quadratic to actually estimate this piece rather than a linear function. And that brings us to Simpson's rule. Now, it's the exact same idea as trapezoid, only we're using a quadratic here rather than a trapezoid. So here's the theorem. Let f be continuous on a to b, just like trapezoid. Both functions needed to be continuous. Now, Simpson's rule for approximating the integral from a to b of f of x dx is given by this integral is approximately equal to b minus a over 3n. And again, this b minus a over n is delta x, so I could write it like this in this form if I want to, times f of x naught plus 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3. And I keep going back and forth. 4, 2, 4, 2, 4, and then a 1. So I start with a 4, I end with a 4, and I end up with the last one and the very first one having a 1 in front of it. Now note I said here that n must be even. So what does that mean when I say n must be even? Well, n even means that there's an odd number of entries because we're going to start at x naught. So we start over here at f of x naught, then f of x1, 2, 3, all the way to f of xn. If n is even, let's say n is 4. If n is 4, I will have f of x naught plus 4 times f of x1 plus 2 times f of x2 plus 4 times, f of x3 plus f of x4. So there's my, I started with a 1, ended with a 1, there's 4, 2, ended with a 4 before I go back to 1. Of course, all of this, if n was 4, this would be b minus a over 3 times n, which is 4. Now the question is, what is b minus a? And then I actually can work out Simpson's rule, or using finding the approximation of the area under the curve based on Simpson's rule. So that's what Simpson's rule is all about. It's this relatively straightforward, simplistic formula, and we just apply it to a function.